So I started this little project off a few months ago, and I'm just getting off to finishing it today. But before I did, I thought I'd make a quick YouTube video on it. So if you're watching this, you're probably wondering what the hell this is. You know, there's like a black box with a little PCB on it and some connectors branching off of it. Well, decided as I've been messing with my stereo and other stuff, speakers and stuff, I would build a little amplifier that I could use for my earphones, because the device that I use to listen to music, I could use like my phone or whatever, but I choose to use this little MP3 player. The amplifier in this just isn't loud enough. And I'm now in college and travelling on the bus. I literally can't hear the sound playing through that MP3 player. Even on full blast on a loud song, it's just so quiet. And I mean, I thought it'd just be fun to mess about with this little project. And the PCB in the... well, let's do a layout first. So this black box that the PCB is on is a 5 volt portable battery. It's a USB one, so you can plug anything that has a USB into it and it will provide 5 volts. I think about 1 amp or so it claims it's rated for, which is enough for this type of amp. I mean, this uses 3 watts per channel, so it probably isn't 3 watts. You know, the max is probably about 4 watts the max before this thing starts clipping, and it does actually start clipping, which is kind of nice. So I got this off eBay, this little power bank, for about £3 something, so it's not too awful bad, and you can charge it up. You just have to plug another connector in. You can charge it up when it gets low on power. Now, I'm not sure if it has like a safety cut off. I know it has like a little LED inside, which is blue when it's charged. I'm not sure if it goes to red when it's running out of battery, but I'll have to find out anyway. So that's the thing that I'm using to power the amplifier. This little board here is a very small amplifier. I got this off eBay. It's based off of a PAM IC. PAM 8403 IC, 3 watts per channel. It needs 5 volts to go into it, and there's your input connector, which I'm just using a 3.5mm audio jack, which can plug into iPads, anything that uses 3.5mm audio jack. Can plug it into my computer if I wanted to amplify the sound coming out of that, and that's just soldered onto the PCB. And the USB connector soldered onto the PCB, and I can just spin this around and plug it into the power bank, which means the amplifier is getting 5 volts, which it needs to amplify the sound going into the input correctly. Then going to the output, I have this 3.5mm female connector, which I can plug headphones or whatever I want to into this. I can use this as like a preamp for my stereo up there if I wanted to, but anything that has 3.5mm plug, audio plug, I can just plug that in and it will give an output. So this is capacitor coupled. It uses some little ceramic capacitors, kind of nice to see. And this amp, well, it is actually an amp, it's an amplifier IC. It clips, if you turn it up too loud and it draws too much, it actually starts to clip, and you can hear the headphones actually quieting or going quiet when it does start to clip, and at that point you know to turn down the volume on the input. So that's kind of nice, because it means I'm not going to be blowing up my headphones, because I don't think it would be very nice to have a pair of earphones explode whilst they're in your ear. They probably wouldn't do that much, they'd probably just give off a little puff of smoke. I don't know, I've never tried overvolting a pair of earphones. But then I've just got the output wires soldered. There's the ground and there's the signal. And that's pretty much it for the hardware. All these wires I got off used devices, like a pair of broken headphones, Turtle Beach ones which are broken. And you know, I just found them laying in my box of wires and stuff. Now I decided to secure this to the battery pack, and I'm going to use some black electric tape. Now that I've secured all this down with some super glue and some silicone, I'm going to go over it with black electric tape just to help isolate it even more. So none of this will be exposed when it's finished, but I just thought I'd show you before I do go over it with tape. So the audio PCB, I didn't feel comfortable super gluing it down because super glue is liquid and it does solidify fairly fast, so I just put some double-sided tape down, stuck this down with the double-sided tape, and then just put some silicone around the edges of it, and that's all dry now and pretty solid on there. And then the wires, because I don't want them getting tugged on, and I don't want them, you know, when I turn them like that, I don't want them to be tugging on the solder connections, because those solder connections are very small and fragile, and they will break if you do tug on them or twist them. So I super glued these wires down, and the only point they move at is before the super glue. So the solder joints and the wires are safe, which is what you want on this. And then afterwards, again, going over it with electric tape. And I'm going to give you an example. Turn on my little MP3 player here. So I'll just set my camera and plug in my earphones. So this is without the amplifier. Just I'll play like a dubsteppy type song just so that nope. Okay, so that's at full volume. Don't know if the camera's picking that up. So, I'm going to hook up the amplifier now. And to do that, I just bend this USB cable around, plug it in. A very small little LED there. And I plug that into MP. Make sure I turn it down, because if not it's going to instantly clip. So it's on halfway the volume. It's now on halfway. I can go louder. And it's just starting to click. So as you can hear, it's significantly louder, and which is what I aimed or wanted when I was building this. And on these are ceramic earphones, so they go right into your ear and have the rubber seal. But on a normal type, like the open type that don't have a rubber seal, I actually tested it, and it was just insanely loud. And I dare say that on the bus, people could probably audibly hear that when the bus was driving. So I prefer the ceramic type. This could probably drive a bigger set of earphones. like the Turtle Beach ones that I used to have, and drive them a lot more harder than these little ceramic type, but these tend to clip fairly easy. Either way, they're pretty decent little amplifier board. I only got it for 99p off eBay as well. You can buy these in bulk, I think about 10 for like $3.99, but pretty decent price to be honest. So I'm going to finish this up and you'll see the finished product. Here's the original MP3 player sound. You can barely even hear it. So I'm going to turn this down to halfway and put the amplifier. It's on halfway, by the way. And that is that's nearly full blast. I can't turn it up to full blast because it'll start to clip. But even on halfway it's louder than the MP3 player. The amp in the MP3 player. And at halfway it's getting to the point where I want to turn it down. And past halfway it's at the point where it's getting too painful to actually have in my ears to be listening to something that loud. So this was definitely a success, and you can actually be able to hear some music whilst I'm on the bus. So that's good, and I guess it'll have other uses as well, but just a fun little project. Here's a look at it. Sealed it off with electric tape and just wraps that massive wire around. I don't know why I put such a big wire on that output connector there, but I'm not even sure how well this is even going to fit in my pocket. We'll have to see, but it works at least. Just depends how portable it is. It's a good job that my actual pockets are pretty big, so should be okay, but if it doesn't work out well, I'll do an update video on this. Thanks for watching this quick little project, and see you in the next one. So here's just a quick update on this amplifier project. Now I know I only said that I would do an update segment to this video. It's something I wasn't, quite right about this amplifier that I built. However, I found something out about it last night. And I thought, I asked some people what could be causing what I'd found out, and it's actually pretty interesting. So I'm just doing an update video explaining what I found out. Anyway, the amp works perfect. I used it on the bus, and shown a few people on the bus and stuff, and they were pretty impressed by it. Might even be building a few for some of my mates, but that's off subject for what I'm going to be talking about now. Last night at about 11 PM when I was going to sleep, I like to listen to music before I go to sleep, by the way. So I put my earphones in and plugged them into the female connector on the amplifier. I then plugged the USB connector into the battery so that the amp was running, and the background hiss was audible through my headphones. And I was using my MP3 player. Now I didn't have this plugged into the MP3 player, and I had it about there on the screen when I was turning this on, and I turned on my MP3 player whilst holding this wire near it, and as soon as I turned the MP3 player on, I heard like a weird it was the only way I can explain it was like a weird frequency coming through my earphones. So I turned the MP3 player back off, and the weird frequency noise went away. So I was kind of faffing around with it and turning it off and on and moving the connector away. And I found that this cable seems to be picking up electronic frequencies from various electronic items like my MP3 player, my stereo, my TV, my computer, mains, socket plugs, my stereo clock. Basically anything that's electronic, and it doesn't matter what voltage it is, if it's like a real low voltage or a low current, it still is able to pick up the frequencies from it. And I was really quite fascinated because I was going around and putting this wire near things at about 11 PM at night, and I didn't know how to explain this because I haven't really done much about AM frequencies, so went on to Badcaps and I started a thread. Just posted a few pictures. Then Tom66 replied, and he says that my device is acting like an AM detector. And the input on this is very high impedance. And he was just explaining about how the amp IC works, if it's CMOS or JFET based. I have got the IC, the Amplifier IC datasheet up here, and I've just been reading it. And Tom is correct. And it's sort of like you can buy, I think they're called volt sticks, which you can use to scan across the walls to see if there's like a wire or something behind it if you go to drill. It's acting like that, and it's a similar principle how they are built. They use an amplifier at a very low impedance to pick up the AM frequencies, and AM is what's used in electronic devices. And I don't know if I'm going to be able to film any of this on the camera, but I'll just go through a few things I was testing here. Now the most fascinating thing that I tested was my TV, which is a Pioneer Kuro 428XD 42-inch HD plasma TV. That gave off the most interesting result. My stereo as well, the vacuum fluorescent displays in this also gave off a very interesting noise. So here's what I tested so far. I tested the plug socket behind my pillows here, and putting this connector near them, I could hear the usual AC buzz. If you ever go near a step-down transformer, or any type of transformer really, you'll hear the AC current normally has like a buzzing noise to it, or a hum, as I described it on here, and that was pretty usual for the plugs. And then I checked my iPad. Now this is an iPad 4, and the LEDs that light the LCD screen are located at the bottom here, so they run along on a strip across the bottom. And you know, I was testing around here and I got a bit of a whine noise about where the camera is and nothing else, you know, really much interesting. And then I moved this down to the bottom of the screen where the LEDs are, and I could hear a very audible ticking, and the brightness was at full brightness at the time. This ticking varied in brightness with the iPad LCD, so if I was to turn it down to the minimal brightness, the ticking would be slow and less audible, and on full brightness it was very audible and fast. So now I know why this is because the controller that drives the LEDs pulses them on and off very fast to help maintain the refresh rate of the display. This is how most LED LCDs work, and the LEDs get pulsed on and off very fast. I'm not sure if it's the same for LEDs, well, I know it's not the same for other LEDs, but in LCDs it is. So that was my iPad that I tested with this. And then after that I did my PC power supply. In standby I could hear the whine of the standby circuit. And then as I engaged the power supply, there was a sort of a buzzing noise, and it sounded like oscillation was happening. Probably because there was no load on the output. I was just running it, just testing it basically. And then I did my light switch, which is dimmable. And again, on the minimal brightness, the AC hum was less audible, and on full brightness, the AC hum was like it was from the plug socket. Then I did the LCD TV downstairs. And when I put my little connector near the inverter, where the inverter is located, the inverter has a very high pitch not buzz noise to it, and I could hear that coming through and going to my earphones. And you can actually hear the noise if you're stood near the TV, but with this I could hear it a lot better, and I could hear it's sort of varying. It is really difficult to explain this, but and I moved then the connector to the power supply, where the power supply is located in the TV, and again I could hear that similar switching mode oscillation loop going on, so it's pretty standard. So after that I then did my TV, which was my most favourite thing to test because it's quite interesting, and it would be the same for most other plasma TVs. I haven't bothered to test any at the minute. I have a few to test though, 50-inch Samsung and a 42-inch LG in the other room, which I could test. Now I'm going to see if I can try and capture this. Now the display at the minute is on, however it's primed down to the minimal black level. I'll just unplug my light here. You can see that the display is actually primed up. You can see the contrast between the frame and the actual plasma display. Now on full black I could hear the sustain boards and the plasma display running, and then when I was to bring it up onto an image like this, I could actually hear the sustain boards and the plasma display actually working. Now the camera is actually picking up the refresh rate of the display and the impulses going to the pixels, and through my little amp here I could hear the impulses going to the rows of the screen. And say if I was to bring up, well no, just use it. Say if I was to bring up a moving image across the screen like this, I could hear the rows get scanned by the sustain boards, which, you know, was really interesting because I don't know, I just like plasmas. Then I decided to bring up some colours on the screen. I brought up a red, well, actually that's a better example. Windows 10 is playing up at the minute. How do I get this onto full screen? Oh, it was on full screen. But I was bringing up a full screen image, like a red, a green and a blue. And on a full red screen the buzzing was sort of lower pitch, and on a green, full green screen it was higher pitch than the red, and on the blue it was sort of the red and green noises of the plasma display combined. And the camera isn't picking this up too well, it looks pink on the camera, but in real life this is actually a very vibrant red. But I then put it on a full white screen, and I could hear the display like prime up properly, so it was on its full brightness. It is really interesting. What I'm going to do is I'm just going to turn it off. I'm really picky about getting image burn on the display, so I don't want to leave it running with my light back in here. There we go. So I'm going to hook my earphones and the amp up, and I can see if I can capture some of the electronical noise that I've been picking up. Okay, so hopefully you can pick this up. Here's the vacuum fluorescent display on my stereo. If I was to actually play music, and there's like little counters that come up on here, when they change you can actually hear the change in the frequency. Now, I really hope you can hear this. I'm going to try my best. Now, I'm not even near the plasma display at the minute, and I can hear a very audible buzzing coming from it. It doesn't help with people shouting in the background, but I'm getting near the Y sustain. I really hope you can hear this. If not, I'm going to be kind of annoyed. And you can actually hear this when you're stood near the TV. You can hear the Y sustain buzzing slightly. You can hear the plasma glass. X sustain, or X drive and Y drive as they're called in Kuros. Now I'm going to bring up an image. Let's see what I can bring up on my computer. Right, so actually this is kind of useful, even though it's not supposed to be like that. So let's go near the Y main again. You can hear that it's actually sustaining quite a bit more. Now here's the black pixels, the red. You can hear the change, well, I can hear the change in the frequency. And on the white, you can hear it again. It is really very interesting now. I really don't know if you can hear that on the video. I sure hope so, because if not, I've just spent a few minutes going around my room looking like a dork. But I'll increase the audio volume in Sony Vegas. So yeah, I now have an AM detector from a simple amp project that was supposed to be for my earphones. So thanks for watching.